If you're still manually building Ubuntu templates in vSphere, you're doing too much work. Step-by-step installs, manual configs are slow, error-prone, and just don't cut it in a modern CI/CD pipeline. Templates should be fast, consistent, and ready to go with zero guesswork. In this video, I'll show you how to automate the creation of a vSphere-ready Ubuntu 24.04 template using Packer, fully configured with Docker, cloud-init, and more. In the next video, we'll use Terraform to turn that template into fully running VMs automated end-to-end. Let's kick it off with Packer. All right, so here's our vCenter UI. And what we want to do is create what I already have here, the Ubuntu 24.04 template in the templates folder. And this I've created multiple times. So what you can do is iterate over it, meaning that you don't have to delete it to create a new one, which is great if you have this as part of a CI/CD pipeline. So basically what we're going to do is run Packer once again, and it's going to override that template, as we'll see in just a little bit. But first, here we are in our repo, the same repo we use for Proxmox. We're using it here for vSphere, and we have a Packer folder and a Terraform folder. For the Packer folder, we have a few files here, but let's focus on the README file, which is quite comprehensive in terms of how to run this. And the versions that we're using here is vSphere, vCenter 7.0.3, and an ESXi host version 6.7, Packer 1.12.0, and Ubuntu 24.04, of course. The prerequisites is to have Packer installed on your machine, access to a vSphere environment, and network connectivity to be able to download your Ubuntu 24.04.2 ISO file. Features, we're going to be able to create a fully automated Ubuntu 24.04 template VM in vSphere to be able to use that for creating VMs later by cloning it. Installing Docker with Docker Compose, just as an example to show you how we can pre-install software inside the template so it speeds up whenever you want to spin up a new VM. You already have software installed in it with the version you want. Configure cloud-init for VM customization. Optimize for template conversion with proper cleanup. And then we're going to use a CD-ROM-based cloud-init for reliable deployment and not having to rely on an HTTP server that Packer has to spin up. And then VMware tools are installed and configured. As with regards to our configuration files, we have the variables.packervars.htcl that you'll need to edit to fit your own environment, some VM names and VM CPU sockets and VM CPU cores. All of this is configurable. The memory size, disk size, and thin provisioning, all that is configurable in this file. And then some secret configuration here. I don't want to expose, of course, my vCenter username, password, server address, all that is in the secrets.packervars.htcl.example, which you'll copy into a secrets.packervars.htcl and make the necessary changes. And then we need to turn the script into an executable, which is this build.sh shell script, which will run the Packer commands for us easily. Of course, you can run the Packer commands yourself, but the build script is very handy to do it for us. Packer will create a VM in vSphere using the specified ISO image, and it performs an automated installation with cloud-init provided with the CD-ROM that I just mentioned. And after the installation, we're going to run a post-installation script that configures the system, installs Docker with a specific version of Docker, and then perform some cleanup operations, and finally converts that VM to a template to be used later. The cloud-init config approach, we're going to use a CD-ROM-based approach instead of HTTP. It's more reliable, where we're going to feed in the metadata and user data files. And this CD is attached to the VM during boot, and then Ubuntu's cloud-init detects the CD and it applies the config. And this approach is more reliable than using HTTP. The relevant files are inside this HTTP folder, metadata and user data, which we'll see in just a little bit. And then finally, some troubleshooting tips. And that is pretty much it. So let's go ahead and get started. We need to run the build shell script, and that will go ahead and run us through the Packer build process. And I've enabled heavy logging in here, so you can see that it's showing you everything that it's doing. And right now it's waiting for boot and powering on the machine. You can see the template now is on, the VM is on. And of course, we can come in here and look at the logs and see that it's typing in the boot commands to enable auto install for Ubuntu and to start generating the cloud-init configuration for us. And it's waiting for an IP. So this will take quite a bit of time. So be patient with it until the very end. It will keep working in the background. So what we'll do is we'll pause the video and we'll come back once this is complete. And there we go. We see the machine has shut off here, and you can see it also that we now have a template. It's not running. So it's been converted. It's not a VM anymore. It's been converted into a template. And if we finally go back to look at our Packer builds, that you can see build process completed. And you can see it took 26 minutes and 27 seconds to finish. And that is it. Basically, we have a running template now that is available, and we are able to convert that into a VM by cloning it. Of course, you can do this manually, but why? We're trying to move away from manual work and automate everything. And that's why stick around for the next video. We're going to use Terraform to clone this template and convert it into a running VM so you can see the entire automation process end to end. Thanks for watching, and I'll see you in the next video.